What's going on, everybody? Hey, hey. All right. Go ahead and put in the chat if you got something cool to say. But this is the first Life Cycles live stream. So I'm going to give it just a second before I jump in. But super excited. This is just, kind of like one of those things where had an idea, wanted to jump into it, wanted to start sharing more live content with everybody, but wanted to put a little bit more organization around it. But I want it to be completely organic, like unscripted, kind of just, rock and roll. Because that's how I roll, man. And so, welcome to the Life Cycles Live first episode. This is going to be dedicated to the life cycles of people, assets, all the things. I want to get to know people. I want to get to talk about different types of assets, different types of equipment, different methodologies. We want all of it. So if you have comments, don't forget to drop them in the chat while we're going, and I'll introduce you guys to each other. And if you don't know each other, and we'll have conversations about cool stuff. But I want you guys to win. I want this to be interactive. I want it to be community building, right? So my name's Lucas, for those that don't know me. I'm a life cycle manager / engineer and integrated logistics support manager at a company named Amentum. And my primary support customer is the U.S. Navy, notably the Columbia Nuclear Submarine Program. And I also do work with other areas of the submarine enterprise at NAVSEA as well. And my big focus there is just logistics engineering and program management. So I love doing that kind of work. It's what, really is rewarding and exciting for me at this phase of my life. And next to that, my other passion is being an entrepreneur. For those that know, I'm the founder and owner of eastpartnership.org. If you don't know about East Partnership, a little bit about us. We're basically a learning organization. We try to bring the industry-leading entrepreneurs to people, to learners that are seeking knowledge from leading entrepreneurs. And we've got course lines and everything from asset management to RCM to life cycle management, the stuff I'm doing like maintenance task analysis and level of repair analysis, more traditionally known as logistics engineering or supportability analysis. And we also have affiliate relationships with Reliability Center and with PM ProLearn. So we can bring those people that already host their own on-demand or even live courses to our audience as a partner. We don't have to be the ones creating all the content. We want to share with everybody, right? So anyways, that's our thing. And East is just really, we're focused on trying to help people that are either maintaining or managing complex assets. So big, fun stuff. And if you don't know about Reliability Center, they specialize in root cause analysis, but they do much more than that. That not only do they teach courses in root cause analysis, they also consult in this space, and they own software. EasyRCA is their newest package. Is fantastic. So check them out if you haven't already done that. So yeah, I want this to be a fun show. It's going to be frequent. I'm not sure exactly how frequent, maybe once a week for right now, maybe even more. I want it to be spontaneous. I don't want this to be fully scripted. I want you guys to interact in the chat and we can have conversations. And I don't want to spend more than just a few minutes on each topic, right? This isn't a sales pitch. This isn't a place for me to just tell you all about the things that are going on with my life. I want to be talking about you guys. I want to be talking about what's going on in our community and with our industry. So eventually we're going to have some guest speakers. And this idea is about 10 hours old, so I haven't had a chance to really invite anybody yet. I didn't want to spring it on them and be like, hey, you want to go live at 4 o'clock? So yeah, I'm going to be engaging with people that we have network, people that you may or may not know, because I've got a pretty broad network. It moves out vets, non-vets, US, Canada, whatever. I want it all. So, bring me your ideas, bring me your people, bring me your topics, and we'll hash them out. So cool. So what's going on in work? So with my work with Team Submarines right now, we're doing some logistics support analysis for the Columbia submarine program. And I'm pretty psyched about this stuff because it's huge, right? We've got this very large responsibility and we take it very serious, but we also really enjoy this work. And so right now the submarine's design's been pretty much stamped, and we're in the process of developing all the support network information and data to support this massive asset, this nuclear submarine. So everything from maintenance requirements and tasks and plans to strategizing the resources for those maintenance activities, training, all the training stuff that's needed. What's going on, Dylan? Out from Edmonton. Yes. So glad to see you, man. I was hoping you'd be able to call in or chat in. Hey, do me a favor, drop something if you want to talk about a particular topic or whatever, because this is fully organic. I want it to be fun. And yeah, so we're doing really cool stuff with that. We're also building a lot of strategy for Columbia. And a lot of that strategy is like life cycle planning long term, like how often should we do major maintenance on this thing? How many maintainers are going to need at the facilities? What type of skill sets, special equipment, tools, all this stuff that comes along with life cycle support for a major asset. We call that sustainment in the DoD space. We call it a sustainment activity. And we're fortunate in the Department of Defense to have these very capable teams and very capable organizations to support us. But that's because the Department of Defense takes this stuff seriously and they invest in it, right? So message to those in industry, if you want that same level of support, you have to be intentional about building it, right? This stuff doesn't just come about. And you don't have to hire all this stuff. You don't have to just bring someone in to build all these things for you. You can build them yourself, but you have to make sure that you do it intelligently, right? That's where the logistics support analysis comes in. It helps us understand the requirements to support the asset. And you can align all that stuff with your asset management plans. And I'm not the asset management whiz. I would defer to someone like Suzanne Greenman for that type of info. But it all comes hand in hand where asset management's that really strategic view. And hull, mechanical, and electrical playground of things to maintain and figure out how to maintain and when to maintain and how to document the maintenance requirements specifically, and then of course developing all this stuff that goes around that. So my personal kind of opinion on how this should all work is that you should look at it through what's called an activity-based maintenance perspective. And I robbed that title and badged it in my dissertation, but the reason why I stole that is because when I was in the Coast Guard, there was activity-based costing. And rather than look at the cost of a thing, they were looking at the cost of an activity, the total amount of money it would cost to perform some activity. And I thought, well, that lines up perfectly with maintenance, because maintenance programs don't fund a part. They're not funding, we don't build the budget on a part. We don't build the budget on the cost of a system. We build the budget on the cost of maintaining that system, the activities it takes to do that work. So that's one of the reasons why I default to what I call activity-based level of repair analysis, or activity-based maintenance perspectives, because I think if you start to look at maintenance as an activity and wrap all the other costs into that, it's super powerful stuff for helping to build a budget, right? So instead of saying how much money does it cost to maintain this engine, you say how much money does it cost to fund the maintenance program? And the maintenance program isn't full of equipment, it's full of activities to support equipment. And so you start pricing out the activities, right? And of course you can tuck those activities under certain pieces of equipment or systems. And you can say, well, this system is comprised of these activities for planned maintenance. And then you can even pull your corrective maintenance items that you've had historical context for into that same world of work. And it works, right? But you're looking at the cost of the activity. So that's just my little nugget about activity-based costing that I thought I'd share with you guys today. It's not something that you really find published in too many places. It's merely the perspective of a guy who's in complex systems. So that's my gig. Hey, before I get too much further, I did want to give Dylan a chance to ask a question or pose a topic. Dylan, you got something you want to talk about? Go ahead and throw it in the chat, man. Hopefully you're still with us. and I'll jump right on it. Even if it's like, hey, what's your favorite football team? American football team. I'll say the New York Giants. Sorry. Any Dallas Cowboys fans out there? You just need to rethink your life decisions. All right. Let's see. So what else is going on? So outside of that kind of work that we've got going on, we're also doing a lot of model-based systems engineering. Ooh, hold on a second. Why don't equipment designers think about maintainers when they design equipment? Great question, Dylan. Okay, so why don't equipment designers think about maintainers when they design equipment? This is going to be a little surprising to you. Some of them make a very concerted effort to do just that, and others absolutely not, right? So when we design ships, we consider what's called human factors, right? And so we have engineers that specialize on human factors engineering, and we also have human-centered design. You know, all the different things you're going to hear about being thrown around in industry these days as a focal point in our design effort. Same as like systems engineering used to deal with back in the day, where we said, hey, why aren't we taking a systems perspective to the design of these different components, because they work in a system and not just on their own. So the same thing with designing for the maintainer. So you've got design for maintainability, right, which is a design criteria that says I need to be able to maintain this piece of equipment. And then you've got the disciplines of human factors engineering and human systems integration, and you take those two and you bring them over and you mash it all together with the design engineer, and you say, look, integrate the human into this equation. Who are those humans? Well, those humans are operators and maintainers. And so you have these things called maintenance envelopes, which you build around the components or around the piece of equipment. And all that is a fancy term for an area around the component that you have to perform the maintenance on. So you can build out a maintenance envelope around a component in a system. And a good example of companies that do this, or at least used to do this, I don't know if they still do, Nissan used to make very maintainable trucks, because most of their trucks were being used in certain applications, right? And they were trying to make maintenance as easy as possible. I don't know if that's still the case, so don't burn me at the stake if it's not. But yeah, it's very important. Now, this like lends itself to whether you're going to choose as a consumer to prioritize that for that asset, right? And if you're creating large, expensive assets, like let's say a medium or a large or a high-powered diesel engine is a good example, and it's something people are familiar with. Maintainability and the feasibility of support is going to be huge for the purchaser, right? So you're going to be looking at how difficult is it going to be for me to maintain this equipment. What we often screw up is we'll buy something that's very maintainable. We'll buy something that did have human factors engineering involved in its design, that thing, and we'll put it somewhere that did not consider this. So you could have an engine that internally is configured for ease of maintenance to a certain degree, right? Well, the head is easy to take off because there's only 8 there's only 8 nuts or bolts on the head, depending on the design. And you can do it with some fairly basic tools. And there's my dog. And you can get to this thing pretty easily if you have a certain amount of clearance around the engine, right? And then we buy this thing and we shove it up against a bulkhead or a wall in a factory or in a facility and completely intrude on that maintenance envelope and completely defeat the point of the design engineer. So sometimes it means the component design engineer did a good job, but the installer or the purchaser failed to carry through. And other times it's the exact opposite, where we don't do a good job of either of it. And we design a poorly maintainable piece of equipment or a difficult to maintain piece of equipment. We don't incorporate the human factors elements or the human factors themselves. And we fail to actually say, well, what do we need to do to maintain this piece of equipment, right? What do we need to do to sustain the functions of the piece of equipment to maximize its operational availability? And we completely screw it up. And then who finds out is the guy who's got to get on his back, or the gal's got to get on her back and get to that pump, get to that bolt, get to that cap, whatever, and do the task that we've asked them to do. and they're going, who the heck designed this thing? Right? And anyone who's ever turned a wrench has said those exact words. I own a 1969 Dodge Coronet RT. It's a 440 big block. I love it because it's easy to maintain, right? Much easier than my 2019 Dodge Ram. And that's not terrible to maintain, but it's not as easy as my 440 in my 69 RT, right? It's just different. Yeah, so Cat, you need a special tensioning device, right? Yep, to take the 3600 series heads off. Yep, absolutely. And with the Waukesha, you can do almost anything with a 1/2 inch impact. Yeah, so they consider that in the design of the asset. And that's huge because they've incorporated the maintainer in their inputs in the design. And they know that some customers are going to make this, purchasing decisions off of that type of stuff, right? So if you go to, yeah, and I like your point about pump skids and complete setups, right? Because a lot of times those skids take away the guesswork. You don't have to figure out how to configure the components. It's all prepackaged, and all you have to do is get it on its foundation or whatever, right? And they've built that envelope into it. They've built the configuration into the item, and it removes some of that risk. Dylan, those are great topic, man. That's a really good stuff. So I did this on a landing craft, and Hank Kosovar, if he sees this, big shout out to Mr. Hank, who is one of my mentors on this program. But we had to work with the design engineers to build a ship, and the engine room was really tight because it's a landing craft and it had a very low profile. And the engine room wasn't built to be stood up in and constantly manned, right? It was considered basically an unmanned space for watch purposes. But you had to be able to go in there and perform basic organizational or O-level maintenance. And you had to be able to go in there and do corrective maintenance actions that we predicted. So we had to work all those maintenance actions into the design. And we took the OEM's information, right? The maintenance tasks that the original equipment manufacturer provided to us. And we said, okay, for us to do this work, you need this much room. Build that into the CAD model for the ship. And they built those envelopes into the CAD. And then when we'd open up the CAD model, you could put a filter on it so that you could see the maintenance envelope around the piece of equipment, around the engine, whatever. And they would identify risk areas in the design. Oh, well, there's a stanchion or a pole or a walkway or another piece of equipment within that maintenance envelope. What do we want to do about that? And so the reliability engineers, the maintenance engineers, and the program managers, we all got together and said, all right, let's do a review of the design and see if we can fix that. And if we can't, we'll take the risk, but at least we know it exists and we can document that and give the Army recommendations on how to overcome that. All right. So Dylan, you got any more on that? That's cool, man. All right. I'll keep hustling. If you put some stuff in there, we'll come back to it. I only want to keep this to about another 10 or so minutes, but I'd much rather talk about that kind of stuff than stuff off the top of my head. Thanks, Dylan. Hey, by the way, something else to think about when you're out in the field and you're maintaining this stuff, if you find these types of things, don't be afraid to bring it up with the original equipment manufacturer if they're the kind of person that collaborates with their end users, right? Because they may incorporate that into future designs. So although the current design may completely suck, if they get enough complaints about it in the future, they may actually do something about it. They may also ask you guys for input on applications. So if, let's say you buy COTS, right? You buy this engine, COTS, like commercial off the shelf, right? You buy this pre-assembled, pre-designed, pre-configured thing, and you want to put it in your facility. You can oftentimes have them come in and say, and all you have to do is ask the question, look, I need to optimize my maintenance capability here. I've got a limited space and footprint, obviously. Can you guys come help us assess the installation point or location and identify what we are going to have problems with? Because even though you may not be able to get around those issues, right, just because you have these constraints that you can't change, it doesn't mean you can't be aware of them before you go to do the activity. So let's say a maintenance procedure is prescribed to be 30 minutes long. right? You get out the maintenance procedure and it says this task should take 30 minutes, but it actually takes you an hour and a half because of interferences, right? Or whatever. You don't want to find that out when you're going to do the maintenance and you've only allocated 30 minutes to schedule it, right? And then you go perform the maintenance the first time, and that's when you find out it's going to take an hour and a half. And your whole plan for the day is thrown out the window with operations because you had to take the equipment down for 3 times as long as you had previously planned to do. And the only reason you screwed up the plan was because you hadn't actually verified or validated that that time period, that duration was going to be accurate for your application. And I'll spare you a lecture on maintenance task analysis, but this is one of the reasons why I highly recommend when you purchase something complex that has a predetermined maintenance suite, that you go perform a rudimentary or a quick maintenance task analysis and try and perform some of those activities, or at least walk through them. You know, you can just take out the paper and say, hey, do I have all the tools? Do I have the room? Oh, wait, it says at this stage, I'm going to have to get to this point. And you're looking at it and you're going, dude, there's no way that's going to take the 5 minutes that they're prescribing. There's no possible way, right? And you can adjust that duration and publish it for yourself. So you have an accurate maintenance task duration. All right. Yep, you had a discussion about this with a motor manufacturer, a skid manufacturer about a lube system. Yeah, yeah. A 10-inch Y strainer. I can't, change the strainer without taking the whole strainer out. Yeah, the whole assembly, right? It's connected to a gate valve with studs. Yeah, see, this just isn't fun, man. That may not have been clear. Literally, we had to fully pull the entire Y strainer. Dude, that sucks, right? So you have to pull this whole thing apart. This used to happen to us a lot in the military with aftermarket flexible couplings, right? Flexible hoses. They call them flex hoses. They're actually like a piece of pipe, right? It's like a rubber piece of pipe. But they're made to flex and move with the ship because the engine's on a mount and the ship's moving. You got these dynamic forces, the piping, everything's kind of wanting to move. And so we used to have to fit these flexible hoses in between these flanges. And there were times when they would make it so that you couldn't get the flexible coupling out. And, because of the structure of the ship, well, that structure of the ship didn't exist in the design of the coupling. So they get you to fit it right in where you need it to be, right? Yeah, like a flex, yeah. And you end up taking like 10 feet of piping out just to get the coupling out and realigned properly. And it turns into a mess because now you're changing out a gasket on the pump side that you hadn't planned on doing. And it gets to be a real pain. So I feel your pain, man. I'm down with you on that one. And so, yeah, some of these things you can mitigate in design and others you can't. But there's 2 phases of design consideration here. One is the design of the piece of equipment itself. And then the second is the design of the installation, right? The installation plans. And you can try and mitigate risk on both sides, but you have to be intentional about it. And I'm very big about being intentional if you haven't noticed that yet. Very cool stuff. I'm down with that. That to me is a huge problem. For those that have never touched these things, that haven't worked with it, they don't understand the pain that Dylan's talking about or that I'm over here running my mouth about. It's a real thing. If you're not familiar with it and you're not hearing about it, go talk to your maintainers and have them create a log of these types of interferences, these types of delays. And you can actually make a concerted effort. You can keep a running backlog of these types of things that you can put on a project list to try and mitigate later, right? You may not be able to solve that problem right now, but you may be able to make some structural or facility changes down the road to help mitigate these things if they're significant enough. Or it can just help you make better plans for your equipment downtime when you're doing extended layups or any type of seasonal maintenance or whatever. So good stuff. We used to build them into what we called large availabilities. When we take a ship out of commission for an extended period of time to do extensive maintenance, we would build those big items into that. We call them ship alterations. But basically, it's just any type of engineering change where you're going to go in and change the configuration of the equipment or the surrounding area or the facility it's in to help meet the needs of either the maintainer, the installer, whatever, the operation of the equipment, whatever. So you have that opportunity at that point without impacting the operational scheduling of the asset. So very cool stuff. So we've got about 4.5 minutes till I want to wrap this thing. I'm going to try and keep these to 20 to 30 minutes. The big issue with communicating all this types of information is we're often scattered across many different places. I'm wearing an Upkeep shirt. It's on accident, kind of, sort of. I mean, I intentionally put this shirt on this morning, but I didn't do that with the plan to talk about Upkeep, extensively today. But I do want to take a moment and talk about the Upkeep maintenance community, which is really cool. If you, Dylan, I know you're on there. I'm on there. A bunch of people in our network are on there. But for those that may be watching this later that aren't familiar with Upkeep or the maintenance community, check out upkeep.org. And they basically have this really open, highly communicative, interactive community on Slack. And Slack is a communications app for those that don't have Slack. And it's a great place, no matter what industry you work in, no matter whether you're a manager or a maintainer or both. Whether you're talking, marine, railway, production, manufacturing, pharma, whatever, whatever industry you're in, you'll find something of value in the Upkeep maintenance community. So check them out if you haven't already done that. Also, I'd be remiss if I didn't take this opportunity to talk about Suzanne Grieman, a dear friend of mine at Grieman Asset Management Solutions. She owns a training academy called the Grieman Asset Management Academy. We are fortunate that she has chosen to host her courses with us at East Partnership. And she's got an Asset Management 103 course that she just put live this week. She's rolling out the units daily. So we're up to unit 4 now, I think, is getting ready to go live. She's got 1 through 3 loaded. And that's AM 103. You can check that out at eastpartnership.org. And Suzanne's content is just amazing. She puts a free preview on every one of her classes. Not everyone does that. So you could sign up, just enroll in her free preview, and it gives you a little taste of the format and the quality of her on-demand training. So pretty cool stuff. And if anyone knows Suzanne, they know that she is super professional, and her course is a reflection of that. I've got the Laura course on there, the level of repair analysis course, doing the same thing, rolling that out in iterations. Lesson 3 for mine is about to come out this weekend. That's the economic level of repair analysis, the economic phase of Allura. The non-economic and introduction units are already published, and that's really the meat and potatoes is the non-economic analysis of the Allura. So if you're interested in that, you can go check that out. I've encouraged all of our training partners to bundle courses to save people money. They've all been absolutely supportive of that. So if you go into eastpartnership.org and you're looking around and you see like a whole product line of courses, and you think, wow, it sure would be cool to get in on all those courses and not have to pay full price, you can buy a bundle. It's a little bit more upfront, but it cuts your cost over the totality of the program. So if you end up buying 2 or 3 or 4 different courses, you can get them at a discount, and it's usually at least a $50 discount to give you some perspective. We're not just saving $5-10 bucks. Also, I want to talk a little bit about one little lesson that is kind of related, but not so much related to these topics in this industry. One of the things I do is work with model-based systems engineering, and one of my projects that I provide a certain level of support to. I'm not one of the key members of Project Blue, but I'm one of the support members for Project Blue with the U.S. Navy. It's amazing. Project Blue is really cool. It's we just went live with a LinkedIn page in the last week or week and a half, and my partner in crime at work, Dr. Katie Castell, she's leading the effort. And we're keeping eyes on the page. And so if you want to interact with Project Blue on LinkedIn, check it out. It's really cool. It's basically a combined effort amongst many different industry players to get ship design, ship sustainment, and model-based systems engineering applications such as digital twins and digital threads all brought together, so that we can take advantage of the extensive design modeling that's done for large complex assets in the design phase, and take that same level of detail and roll it into a digital twin of the asset that then can be used for maintenance and support of the asset in its life cycle. So, as the asset ages, you have this authoritative database linked to a 3D model, and you can just go into the 3D model. You can locate the component in the ship or in the building or on the plane or whatever in the facility, and you can go to that component, you can click on it, and when you do that, it opens up a library of authoritative data sources for that asset or that component. So if you went to that pump that Dylan and I were talking about, we were complaining we had to maintain, and you were getting ready to perform the maintenance, you could go into the computer, locate that pump in the facility, click on it, and it would open up all the information you would need to sustain that piece of equipment. It would have the maintenance procedures. It would have all the supply data, part numbers, nomenclature, everything. It has linkages to the training materials if they're embedded. If not, it would take you to those training materials elsewhere. It has all of the configuration data in the system. So super powerful stuff. And the cool thing is it's all up to date because it's all tied into the authoritative data source. So that's really what Project Blue is striving to do for a single Navy application right now. But I have no doubts that this will be bigger than what we are currently doing in short order. So big shout out to the Project Blue team that's doing great stuff there. Dan McMath, our partners at Beast Code, the Amentum team, Electric Boat jumping in on it recently, and so it's all coming together, and it's a big lift, but it's worth it, and I'm excited to see where it goes. So if you haven't checked it out, check it out. And then the parting thing is kind of related to that, not necessarily to Project Blue, but to the application of Agile frameworks or methods or whatever. You get people that call it what they want. But Agile is like a keyword that's thrown around these days, and not many people understand it. I'm one of the people that's worked in Agile. Our members of our team work pretty heavily in Agile. I'm not a software development guy. I've used Agile in other areas, non-software related areas, where we integrated software into non-software applications, not just hardware for computer systems, but into sustaining things like submarines, right, or ships. And you end up with a clash of like two different cultures in this world of work. You end up with this super agile software development focused kind of world, and you're working with what's a lot of people would refer to as a rigid kind of bureaucratic, high level of requirements, high level of scope kind of world of shipbuilding or detailed design and detailed systems engineering applications for complex systems. And the two they work extremely well together when you can figure out how to strike the right balance of bureaucracy and agility, right? And when you hear bureaucracy, don't think bad. A certain measure of bureaucracy is actually really good. And I'm reading a book. I'm going to butcher this right now. I'll have to clarify this either in the comments when I publish this or not, but it's called Doing Agile Right. And I would love to give the authors credit right now, but unfortunately I'm running a blank. But in the first section of the book, they come right out with it, and they hit the points right off the mark, and it made me happy to see that. And then there's another reference here called Unlocking Agility. I'm sorry, I'm making this so you guys can see it, by Jorgen Hesselberg, and he talks about this a bit in his text as well. But really, what you're trying to do is seek a balance. Right, you're taking a new method or approach into an organization or to another organization like a teammate that doesn't necessarily employ that same approach. And so what you have to do is find a way to make it work together. And that means you're going to have a share of both. You're not going to have all of one. It's going to be a collaboration, right? And if you try to just completely shift the culture overnight, you're going to fail. I have no doubt about it. And it's not that the bureaucratic way is wrong, because we have decades of history showing how the well-defined processes and the well-defined requirements and the well-defined scope, that approach has taken us leaps and bounds from where we were before the advent of those processes, those requirements, those very detailed ways of doing business. And that was one of the reasons we were so successful in the industrial age, is the constant iteration of that world of work drove to better levels of detail. And you could have a very well-defined, detailed, complex thing, and it was going to have significant levels of reliability because a lot of thought went into it, right? and a lot of checking and balancing went into it. And then with software, it's a little different because you're not working with these expensive, labor-intensive physical materials like welding a hull together and then saying, oops, that didn't work the way we wanted, just scrap it and do another version, right? It's not like necessarily like going in the system and working with code. And I'm not saying code is easier, that code's not time intensive, but it's different, right? Neither of them are easy. Both of them involve a lot of time. One comes with a very different expense, right? The physical materials that are involved, sometimes very limited supply of physical materials. And then when you look at the complexity of a physical asset, you often don't have, the opportunity to do several iterations of that asset before you say, oops, we got it right. So think about this, all that to say this, when you try to bring these together, remember you have to have buy-in on both sides. You have to have buy-in from both the side in trying to bring the innovation into the mostly bureaucratic organization, and you have to have buy-in from the bureaucratic organization and an open-minded approach to say this innovation and agility is good for us. And we want to take as much of that as we can and incorporate it into our processes, into our requirements, into our product development cycle. And when you can do that, you'll realize that it's not one method is better than the other. It's that they have to complement each other and have to be balanced. And that really at the center of all this isn't either of those things. It's the people, right? It's the willingness of the people to adapt and learn and apply and make those two things come together and work properly. That's the magic. It's the ability of the people to work together to make that happen. Now, this sounds super squishy and soft. I get it. But you have to believe me on this. This is kind of like if business and the business side and the engineering side don't figure out how to make it work, right? Neither of them are going away. Systems are getting more automated. They're getting more technically advanced with software and robotics and different types of applications that aren't strictly, physical assets like, materials and mechanical and electrical engineering applications and those types of things. As a matter of fact, when I was getting into my studies for mechanical engineering, I decided to study mechanical electrical because the integration of those two things was becoming so prevalent that I wanted to make sure I didn't get left behind, right? And then, of course, everything changed and I ended up as a systems engineer, and that's a whole other story, but you get what I'm saying. We have to be able to make these things work. So that's my learned moment for the day about integrating agile into non-agile environments. And I encourage everyone to pick up both of those books I mentioned, and I'll try and put links into the body below. But my last parting shot is I just wanted to remind everybody to treat each other like human beings, right? Be a human being to each other and do awesome stuff. Big shout out to Dylan. Thanks for calling in today, Dylan, and hanging out with me. And I'm going to have to actually get you on the stream on video here in the near future if you're down for that. So yay. All right, guys, I'm going to close it up. Thanks for tuning in and have an awesome day. Thanks.